Today we're going to look at section 1.7, and this one is about writing proofs. All right, and in writing a proof, we're going to be using definitions, postulates, and theorems. And so we kind of talked about what a definition and postulates were, but what is an actual theorem? We've mentioned it before, like the Pythagorean theorem and stuff. Well, a theorem is literally a conjecture that has been proven mathematically. So when we write proofs, we're kind of writing out theorems or new theorems. That's how theorems are created. We use your definitions, postulates, and previous theorems that have been proven, and you can make new conjectures into new theorems. And so that's the process of proofs. To do this, and you're going to be asked to do a proof on a test, probably one, you want to start making a note page or continue your note page that has definitions, the postulates, and theorems that we go across in the textbook. And thus that's your tools that you're going to use for writing your proof. Okay? It's going to be a big list of things. Here's some words and stuff that you want to make sure you have an understanding of, because we use these quite a lot. You want to know what supplementary angles are, complementary angles, vertical angles, what is a linear pair, and angle addition. We've had this, segment addition, bisectors of a segment. What does that do? What does a bisector of an angle do? What does congruent mean? And what conclusions can I make? So what is substitution? That is a technique for helping us figure things out. What are perpendicular lines? And also any of your basic shape, geometric shapes and stuff like that. You want to know as many characteristics as you can, like squares. If you have to deal with square, all sides are congruent, all the angles are 90 degrees. These are little characteristics that you want to make sure that you know. We're going to be doing a style of proof. There's several different styles. They have two-column proofs, they have flow proofs, they have paragraph proofs. And we're going to use more of a paragraph proof style in this class. But we're not going to go as rigorous as the textbook wants. I'm not looking for heavy-duty rigor. It's not necessary. What I'm looking for is that you're going to go through a logical argument why something is the way it is, and you have to give a reason for each of your steps. And the reason has to be related to something that you've seen so far. It could be one of these words, and things like that. Okay? Definition, supplementary is what's the definition of a supplementary angle, and then I can use that and as my reason for why I'm going to say what I'm going to say. Okay, so that's what we're trying to accomplish here. We're going to do some proofs. I got a couple proofs I want to walk through with you, and to kind of show you what I'm looking for and things like that. So let me pull up a couple of proofs here for you, and we'll start with this one right here. So here's the kind of setup that they give you. A lot of times they'll give you a picture, and then they'll give you some information. This is the given information. This is the stuff you start with. From this, I need to make an argument that shows that this is true. I want to know and show that the measure of angle 3 plus the measure of angle 4 is indeed a 90-degree angle in a convincing argument. Starting with this knowledge right here. So starting with this is true. So in writing a proof, you start with the given information. And here's how you can write it a couple different ways. Basically, you can say given that, and then list what they gave you. The measure of angle 2 equals 30 degrees, and the measure of angle 1 is 2 times the measure of angle 2. That's given. What can I conclude from that? Can I say anything about this information? What does this lead to? Okay. Well, I can take the fact that the measure of angle 2 is 30 degrees, and I can use that and substitute into here and show you that the measure of angle 1 is some other measurement. And so that's what we do. So the measure of angle 1 then must be equal to 2 times 30 degrees, which is 60 degrees. Now, why can I do that? What did I do? Well, I substituted this value into this equation. So that's my reason, by substitution. Now, where can I go? what can I say now? Well, I now have confirmed that the measure angle 2 is 30 degrees and the measure angle 1 is 60 degrees. Well, 30 plus 60 is 90, so I can say that the measure angle 2 plus the measure angle 1, or you can do it the other way around, is 90. Why? This angle measurement plus this angle measurement is the whole measure anglement, that is angle addition. We added two angles together. Okay? Easier to write the word by in here, I forgot it, sorry. By angle addition. Now, what else can I look at? What else can I do? So you look at your picture, you look at your information. I got to get this information into that information. So these 1s and 2s have to become 3s and 4s. I look over here and I notice, oh, hey, angle 1 and angle 4 are across from each other like this, like a scissors action. They're called vertical angles. And likewise, angle 2 and 3 are called vertical angles. And we know by the definition of vertical angles, because we've talked about that in previous lessons, that they're congruent. So I can just simply say that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3 because they are vertical. Or you can just say definition of vertical angles. Okay? So what does that mean? Well, it means that the measure angle 1 equals the measure angle 4, and the measure angle 2 equals the measure angle 3 by the definition of congruent angles. If angles are congruent, they have the same measure. That's what it means. Well, if measure 4 equals the measure angle 1 and the measure angle 3 equals measure angle 2, then I can replace these up here in this equation with the new ones, and I can simply say that the measure of angle 3 plus the measure of angle 4 equals 90 degrees, and again by substitution. And you have now proven this proof. That's how you do it. But you have to have your knowledge of what is available to you, and that's why you need to start writing out what you have available. Okay? Try and coordinate it and organize all this information because it's going to come in a lot of different ways. Maybe have theorems and definitions about segments in one spot and angles in another one, so you can kind of go to them quickly and try and find something that might assist you in your work. I have another example we're going to do real quick. This one right here. And again, we have given and stuff like that in this picture over here. So we want to prove that this angle, ABD, is congruent to FBD. And there's some more theorems and stuff that are out there. And so, but how do we start? We start with the given information. You just write given BD, the ray BD, bisects angle CBE. This bisects this angle. So by saying that, it just told me that this angle and this angle are now congruent. So angle CBD is congruent to angle EBD by the definition of bisected angles. So when I bisect an angle, I'm cutting it into two congruent angles. CBD and EBD are congruent. Okay? So what can I conclude from that? Well, I can conclude that their measure are equal. And that's by the definition of congruent angles. And as you notice, I'm going to start abbreviating words with symbols because it's quicker to write. And that is fine. That is acceptable to me. So now what? Well, I need to look around and see what I have here. And I notice, okay, and this is one of the common things you do, I notice that this angle, ABC, and CBE are a linear pair. I can also state that ABD and DBE are a linear pair, and I think I'm going to take that one better. Okay, so I'm going to say angle ABD and angle DBE are a linear pair. And I'm going to say the exact same statement for these angles. So angle FBD and angle DBC are a linear pair. Okay? What does that mean if they're a linear pair? It means their measurements add up to 180. So that's equals 180, and the measure of angle FBD and DBC is 180. By the definition of a linear pair. And we notice what? They're both equal to 180, so I can substitute it and have one big long string here of all of this information. So these two angles add 180. This one adds 180, so they are equal together. This is kind of a common thing that you try and do, bringing things together by equations that are the same, and I can get this into an equation format. See, if I can try and find a way that these things are the same, then I have these two measures, and then I'm just one step away from showing they're congruent. And we have this, DBE, DBE, and this one is DBC. That's these angles we already determined to be equal. They are equal in measure. Even though the letters are reversed, it's still the same angle. EBD is the same as DBE. It's the same angle, okay? Just written backwards. So I know that this angle right here and this angle right here are the same number. Since they are the same, I can remove them by subtraction. So then I now know that the measure of angle ABD equals the measure of angle FBD by subtraction of equal angles. I subtracted equal measures, right? They're equal. I subtracted them from both sides of this equation. I'm left with this. And so now I can conclude that angle ABD is congruent to angle FBD. And why? By the definition of congruent angles. And I'm done. That's how you're going to try and do this. If you feel more comfortable doing it in a side-by-side, like a two-column proof format, I don't really care what format you use. This is kind of what I do. It kind of flows a little bit better, in my opinion. Again, we're not doing a very rigorous proof, so if you try and compare the proofs that they use in the textbook, they are very strict in their wording and stuff. I don't really need that intensity. I just want you to have a reason for why you're saying what you're saying, and then it goes in a logical progression. It takes time to do this. To do a proof properly, you need to walk through the proof first, maybe making some notes of how you're going to go about doing it before you start writing. You're not going to be able to just start writing out your proof and having it perfect. It's not going to go well. So you need to come over here and walk through this all, which is what I did before I did this proof. I said, okay, this bisects this angle. So that means those two angles are congruent. And so I want to show that this angle right here, ABD and FBD are the same. Well, they're sharing an angle, aren't they? So if they share that angle, then I can remove it and show that these two pieces are going to be congruent too. Okay, so that's what's going on. So once I understand that's what I'm going to do, okay, how do I get to these angles involved? Well, that's the linear pair. Anytime you have angles that form a line like this, then that's a linear pair. And linear pairs are supplementary. So I have that linear pair and that one, and both of them contain the same angles that I need. And so that's how I got to where I wanted to go. Okay? So you look and you walk through it, getting an idea of the blueprint of your proof on the flow of how you're going to do it. Then you can come and start doing the writing. This takes practice, and we will be practicing a lot together. Okay? And so your first off is have your tools so you know what reasons you can give, and then we go from there, okay? And so we'll do a lot more practicing together, and we'll do more in class.